for it, right? And so this is what I'll go into the second part, which is retrieval and context. How do you get a language model to identify what part of the code base is relevant for a task and what part is irrelevant? So before I move on to this, let me just see if there's any questions. Yeah, so there's some questions. Yeah, passing in the schema. Let's see. Yeah, this is a good point, actually. Um, if you use the responses API, yeah, so the new API is maintain state. The problem is that for the old API, it doesn't maintain state, right? So what that means is if every call you make, it kind of has to have the entire payload, the entire history of what's happened, and then the incremental what's going to happen next, right? Um, and so that's a limitation of the old API. Okay, so now I'm going to talk a little bit about code retrieval. And the fundamental problem that this solves is it gives the language model one more thing that it can do, right? Instead of just reading in the entire code base and then trying to edit and solve a problem with it, you give it the ability to read only the part of the code base that it needs to. Um, and so this is a pretty interesting problem. How do you identify what's relevant? How do you get it to read only that? And a lot of the tools that we're using every day, like Cursor, Windsurf, and things like that, are already solving this, right? And I'll show you. So here, we really only want to give the language model code that it needs access to. We don't want to dump in the entire code base to it. And so here, we have some question for the language model. We know that some code is relevant for this question. So maybe we wanted to re-implement some function. So it definitely needs to see the function and the code around it. So we just give it access to that file or that snippet of a file so that it can give us a response. And this is just another way to say that we want to do RAG over a code base. Right? A code base could be millions and millions of lines of code, and we only want to extract out the chunks of a code base, the functions or the methods in a code base that are relevant for the language model. And that's exactly what retrieval augmented generation is, right? I'm retrieving the relevant code from my code base, and then I'm stuffing it into the context of the language model so that the response could be more relevant. Another way to see this is if I have my code base here, so this is a very simple code base, but imagine this is a complex code base, um, and I tell the language model that it has to write some function in the mystring.py file, right? So then, supposedly, let's say the only thing that this depends on is the script itself, right? You have to find a way to identify that this prompt only depends on this file, and so now you only pass in this file into the context of the language model. And this is a pretty hard task because people usually don't. People are people underspecify in their prompts. If you ever chatted with Cursor or these tools, you're not going to tell it exactly what it needs to do. You want it to kind of understand, and that understanding part is quite difficult. Here, I've actually listed out the name of the file. Um, Most of the times, I'm not going to list out the name of the file, right? I'm just going to give it access to my entire code base, and I'm just going to ask it to write a function in the place of another function or replace a function, right? So you kind of have to read between the lines in terms of what functionality the user wants you to accomplish and which part of the code base they're actually referring to. Right? One really, really simple way that you can solve this task of identifying which code is relevant is how Cursor does it, right? Or a lot of these coding tools. You can literally get the user to highlight things, right? So in this example, the user highlights a part of their code and then asks, explain this code. Right? Explain this code is a prompt that is not specific at all. If I asked you to kind of identify what part of the code I was referring to, there's no way that you could do that. The only way that you know is because I highlighted it, right? So how do you know what's relevant? You can literally just ask the user, and a lot of these tools use this extensively. But you can't do this. You can't always do this, right? And even for this particular code, to understand what this code is doing, I could just have, let's say I have a function and this function just calls another function, right? And so in that case, the context that's highlighted is not enough. It would still need to identify what this other function is doing and read that into the context of the language model so that the language model can explain it, right? So this is a first step, but it's not the final solution. The other thing that you can also do is you can do a text-based search. So whatever code you have the user highlighted, you can do a text-based search based on the text that's mentioned here and retrieve other parts of the code base and also pass it into the language model call. And so here, if you've used these tools, you'll notice that they actually do text search as well. Um, they often will just do a grep to look for specific keywords in your code base. And so when they do that, they're basically trying to identify keywords in the query, and they're trying to extract out kind of those keywords that are repeated in anywhere in your code base. Right? Um, and so they use this functionality as well. The problem with this functionality is that it's very keyword specific. It'll extract out the function that you need, and then all the times the function is called as well. Right. So here it messes up because it extracts out uh, not the uh, not the actual kind of definition of this nested list, but kind of something that uses a keyword that fooled it. Right? So really, what you want these models to do is understand the query, the content of the query, and then extract out the part of the code base that is specifically addressing that query. So maybe the function or the class that can solve for it. And so this is more of a semantic search functionality where you can give it your entire code base. I'm just going to see if there's questions here. Yeah, this is a good question. This is a good point. Um, So in my code, I'm literally just reading the contents of the file. Um, I'm opening it and reading the contents of the file, right? Um, and this person is saying that you can actually use a unified diff to apply changes to a file. This is a good point. And even if you look at the Aider bench, Aider polyglot, um, I think they published a blog post. I can't remember, I think it was about a year ago now, where they showed that if you have a coding agent that operates in diffs, it is actually much more accurate than if you have a coding agent that does what I showed earlier. It's a little easier to understand what I did earlier because it's kind of going in and modifying things um, one by one. But they argued that if you give it a unified diff, it functions better. And I also remember one of the reasons they said that that was the case was because a lot of these language models are pre-trained on a bunch of GitHub data, and GitHub has a lot of diffs. So they see a lot of that in their pre-training data, and they're more familiar with that. Um, I'm not sure if that's true, but it made sense to me. Yeah, there's another question here. What do you think about the idea that we use language models to describe all code units, methods, classes in human language, and then we use that description for semantic search? Yeah, this is a good point. I don't think it's necessary. And I don't think it's what a lot of these companies are using. A lot of these companies are using code retrieval models that you can embed chunks of code, and then you can give it queries or similar code, and it can retrieve relevant code. Um, and that works fairly well. So I'll talk a little bit about code retrieval models. So you take your code base, you chunk it. You can chunk it into different functions, different classes, or different files and chunks within those files. And then you have your code embedding model, and you can put the embeddings into a vector database if you've achieved a large enough scale. And then the prompt from the user comes in, and you hit this vector database over here. Right? And so some part of the code base that's chunked into the vector database will be relevant, and then you extract those chunks out and you stuff them into the language model prompt. and then the language model can kind of respond. Right? And so this is one way to embed code and then extract out the top relevant code. And so if you want to think about how code embedding models work, really what they're doing is they're taking your code and they're kind of passing it through this embedding model that's generating vectors, right? Each vector is one chunk, and you define what one chunk is. Right? And the idea behind this is that similar code pieces will be closer together and dissimilar code pieces will be farther apart, right? So in this visual, if you have kind of some concept of a cat and a dog, they might be closer together versus a banana and a cat might be further apart. So the actual vector distance will be further apart. Right? And so typically how I think about this and how I understand this is if you're looking at books in a library, similar books are closer together physically in the library. Dissimilar books are further apart because of the actual classification system that is used to place those books in the library, right? So really what I want to do is take my entire code base and structure it and place it into a library where similar functions are closer together, similar parts of the code base are closer together, and then I can retrieve those parts. Right? And so if you think more concretely about what these code embedding vectors look like, there's code here that I wrote, but basically I asked the language model to give me an implementation of bubble sort. And then I passed it through a code embedding model. I used an open source one. It's the one from Alibaba. It's a modern BERT fine tune. And I asked it to vectorize it. And then here I'm just visualizing the vector, which is 768 dimensional as a barcode. I thresholded the vector and I just plotted it out so that you can see what it looks like. And then I asked another language model to implement a heap sort implementation. And this is what the vector of that code looks like. So I took that entire code snippet, I passed it into a vector, an embedding model, and it generated this vector for me. And then I gave it a third code snippet, which was a Pygame implementation of the game Snake. Right? And so these three vectors, because heap sort is much more similar to bubble sort than it is to a Pygame implementation of Snake, I should be able to kind of see some of the similarities between these vectors. And if you squint your eye, you'll see that the black lines co-occur with the black lines in these two, but they don't over here, right? You kind of see different patterns in the bottom. But it's a little bit difficult. So then what I actually did is I went in and I calculated the distances between the bubble sort vector, the heap sort vector, and that was 0.22, let's say. And then the bubble sort and the Pygame vector, uh, this guy was actually around zero point 0.5. And then the heap sort and the Pygame uh, vectors were 0.5 as well, right? So notice how code that is irrelevant or dissimilar has a higher distance. The vectors have a higher distance. Code that is more similar, bubble sort and heap sort, the vector distance is actually smaller. Right? So those vectors are closer together in embedding space. And if you want to see this in action, if you want to run it, you want to modify it yourself, I have a code notebook here that you can also run as well. Right? So this is the actual code. I've just printed it out here. Um, second. So I asked the language model to generate bubble sort, heap sort, Pygame snake, and then I use this modern BERT base fine tune to generate the vectors. The dimensions are 768 dimensional. Uh, and then I went in and I just created this visual. So you can kind of play around with it. You can modify it um, and see how it works, right? And then this is where I actually calculated the vector distance between them. So this is a good question. This person asks, are constant sized inputs necessary for embedding models because functions are not the same size? Constant sized inputs are not necessary. So if you look at this code, this is the snake game implementation. The number of tokens in this is very different from the heap sort implementation, right? This. Um, so the only thing that matters is that your code snippet has to be smaller than, I believe for modern BERT, it's about 8,000 tokens. It has to be smaller than that maximum context length of the model. Right? That's all that matters. So you can have anywhere up to that number of tokens. That's a good point. So another question here: does it do the search vector all the time a query comes in? No, it doesn't. It doesn't always search it. This is the other thing that when I use a lot of these coding agents, sometimes they will trigger a search. Other times, if you've specified which files are relevant, if the user tells the model or if the user tells the tool what files are relevant, it won't trigger a search. Um, it'll just use those user defined similarity. Other times, if the code base is too large, it'll just automatically trigger a grep first. So it'll do a text-based search first, and if that fails, then it'll go to a semantic search. So it's kind of interesting how they've tiered the searches so that you get really fast and quick searches first, and then if it's a really hard problem, then they'll go to semantic search. So there's another question here. Let's take this. This shows that similar code is grouped together with the embedding models, but the question is, what is the distance between word sorting algorithm and those code snippets? Yeah, that's a good point because the input query is not going to be a code snippet. It could be a code snippet. If the person highlights it, then you could literally turn that highlighted code into a query, and you can turn that into a query vector, and you can kind of uh, retrieve from your vector database using that query vector. But let's imagine the query is just a prompt, right? Write me a sorting algorithm, or rewrite my sorting algorithms in the code base or something like that, right? So now you have to kind of take that query, vectorize it, and then calculate the distance between that query and the actual code of the sorting algorithms. Right? That's a good point. Okay. Uh, I'm running out of time, so I want to move a little bit quickly. So the next problem that I want to solve is that these language models still can't run code, right? They can search for code, they can edit files, read files, but they can't really run code. And if you can't run code, that means that you don't know if the code you're writing is passing tests, if you're going to get execution errors when somebody does run it, and you can't even optimize the code, right? So if you can't run it, you can't understand kind of the memory footprint, the runtime complexity of the algorithm. You can kind of do calculations, but it would be good to be able to run it and get an understanding and